Okay. So can you see my screen? Okay, thank you. So we will start. Mm, So in previous lecture, we have learned about Queen Mcclusckey method, no? Mcclusckey tabular method. Okay, tabular method. Okay, so this is an algorithm. This is an algorithm to simplify a Boolean expression. Okay, Boolean expression. So in our uh, previous week, we have seen that how to simplify uh, uh, sum of product. No, sorry, uh, product of sum of product. No, sum of product Boolean function. No, Boolean function using this Mcclusckey method. Okay, and today we will try to do another example. Okay, and we will do product of sum. Okay, so we will try to do a product of sum Boolean expression. We will try to simplify a product of some Boolean expression. Okay, Boolean expression using this QM tabular method. Okay, QM tabular method. Okay, so before starting that, I want to tell you another notation. Okay, another notation of expressing a Boolean function, Boolean expression. Okay, so have you heard about sigma and phi notation? Sigma phi notation, notation of Boolean expression. Have you learned this before? Have you learned this before? Okay, actually it is very simple. It is just a notation. Okay, so if you have a sum of product, okay, so you can use this sigma notation to denote that sum of product. And if you have a product of sum, you can use this phi notation to denote the product of some Boolean expression. For example, say that if you have this kind of one, if product of some expression, I will this kind of product of some expression, okay, plus a bar b c plus a bar b bar c bar plus a b c, okay, a b c bar, or this kind of function. Okay, so you can see that this is a sum of product. Okay, this is a sum of product. Um, and you can use this notation. Okay, so how to use this notation is that first you have to convert this to uh, Boolean, binary representation. Okay, so this is a product of sum. Okay, so product of sum. So we normally write the what is called the uh, binary representation. Okay, uh, we put 1 if this has a true value, and we will put 0 if this input or variable has a complement value. No, so you already know that. Okay, make a A තිබ්බොත් අපි 1 දානවා, A බා තිබ්බොත් 0 දානවා for sum of product. Okay. So I think you already know that. Okay. So you can write this binary representation like 1, 1, 1. Okay. So here you have to write it 0, 1, 1. Here it will be 0, 0, 0. And here it will be 1, 1, 0. Okay. So this is the binary representation. Okay. And then you can convert this binary representation to a decimal value. Okay. So this is 1, 1. So you know that this is the least significant bit and this will be the most significant bit. Okay. So this is 2, 0, 2, 1 and 2, 2, the power. Okay. The value. Okay. So this value will be 7. No, this value will be 7 and this value will be 3. Okay. This value will be 0 and this value will be 2, 2 plus 4 and this value will be 6. Okay. So these are the decimal value. Okay. And you can write this expression. Okay. You can write this the expression like this f, and you have to put the variable in respective manner from least significant bit to most significant bit, from LSB to MSB. You have to mention here. Okay. Under within the bracket. Okay. And you can use this 5, sorry, sigma. Okay. You can just put 7, 0, 3, 6. Okay. So in that way you can write a Boolean expression using this sigma notation. Okay. Using this sigma notation, you can write a Boolean expression in this way. Okay. Did you understand this? Actually, this is for simplification. Okay. Okay. So rather than writing this kind of expression, it is very easy to write this one. No? Okay. So I think you should be familiar with this notation also. Okay. Uh, because maybe for in examination, uh, instead of a Boolean expression, I will be given this kind of I will give this kind of uh, function. Okay. So you should be familiar with this notation. Okay. So are you clear with this? Can someone feedback if you have any doubts here? So if you have any issue, please let me know. Okay, then I will explain this again. It is not a big one. Okay. So what you have to do is, okay, so you can do the vice versa here also. Okay. So this kind of one you can you can uh, convert into a Boolean expression. So I will give you an example. Okay. I will give you an example. So if you have, if I given this kind of one, okay. So can you write the Boolean expression for this? Okay. So if I give this kind of expression, can you write the Boolean expression for this? Okay. So please take 5 minutes and try to write the Boolean expression for this. And if you have completed, just send me the message. Please try to do this. Actually, still we are in at the beginning. Okay. Yeah, still we are at the beginning. Okay. So we have to learn many complicated things. Okay. So you should clear all the doubts here. Okay. Still we are in learning outcome ones. Okay. So here, there you have to learn about the combinational and sequential logic circuits. And the simplification and analyzing. Okay. And later we will we will learn some com complicated things. Okay, so I hope you should be clear these things at the beginning, otherwise we can't continue. Okay, so please try to do this example, take 5 minutes. Yeah, I got one answer. Okay, let's see whether it is correct or not. Okay, so take another 2 or 3 minutes. Others also can try. Take 5 minutes. 11, 12, 5 we can meet. Okay. 11:25 we will meet. Okay, so try to do this. Okay, we will do this. Okay, so this is very simple actually. I got some answers. Okay, so we will see those are okay or not. Okay, so you can see that this has 4 variables. Okay, A, B, C, D, 4 variables. So this will be your least significant bit, and this will be your most significant bit, LSB, and this will be your MSB. Okay, so this will be 0, 0, 0, 0. These are terms. Okay, so it will be 0, 0, 0, and this one will be 1, 0, 0, 0, and this one will be 1, 0, 1, 0. Correct? 1, 4, 5. Okay. And this one will be 1, 1, sorry, 0, 1, 1. No, this is 6. No, 2, 2, 2, 1, 2 plus 4. Yeah, this is 6. Okay. So if you write the product here, it will be A bar, B bar, C bar, D bar. This will be A bar, B bar, C bar, D. this will be A bar B C bar D. No, A bar B, C bar D. Okay, so this will be A bar B, C, D bar. Okay, so your Boolean expression will be A bar B bar C bar D bar plus A bar B bar C bar D plus A B A bar B C bar D plus A bar B C D bar. Okay, so this kind of expression you will get. Okay. So I think it is correct, no? So your answers are also same. So I think it is correct. Yeah. Okay. So so let's do another example. Example 2, example 3, no? Okay. So if you have a product of sum, this is sum of product. Okay. So if you have a product of sum like this, okay. So you have to use this notation. Okay. Actually, not this. You have to write it in this way. This is the notation as I can remember. Okay. Okay. So you have, let's say you have 0, 1, 5, 6, same expression. Okay. So can you write the Boolean expression for this one? So here it is a sum of product. Okay. So in the sum of product, sorry, this is a product of sum. No? Yeah, product of sum. So in the case of product of sum, you have to, when you convert this to a binary form, okay, you have to convert, if you have 1, you should write the complement, okay, you should write the complement of the variable, and if you have the 0, you should write the true value of the variable. Okay, so in this way, so that is the difference between the sum of product and product of sum. Okay, so you have to use this conversion when you write the product of sum expression. Okay, sum, oh yeah, product of sum expression. Okay, so can you try to do that one also? Take 2 minutes and try to do this. Okay, we will do. Okay, so I think I got some answers from 2 or 3 students. Okay, so we will try to try to do this one. Okay, so this is product of sum. Okay, so you can see that this is 0 and this is 1 and this is 5 and this is 6. Okay, so you have to write the binary representation. Okay, so so this will be 0, 0. So you can see that here you have 4 variables. Okay, and this will be your the LSB and this will be your MSB. Okay, and this is 0, 0, 0 and this is 0, 0, 0, 1 and this will be 0, 1, 0, 1 and this will be 0, 1, 1, 0. Okay, so so this is the binary representation. Okay, so when you convert this binary representation to the Boolean expression or to a sum, okay, so this will be a sum, no, because this is a sum of product. Okay, so when you convert this to a sum, you have to write, if you have 0, you have to write the true value, and if you have 1, you have to write the complement value. So here you have 0, 0, 0. That means A plus B plus C plus D. Okay, and here you have 0, 0, 0, 1. That means A plus B plus C plus D bar. Because this is 1, you have to write the complement of the LSB. Okay, so D bar. Okay, and this will be A plus B bar plus, because this is 1, you have to write the complement, and this is 0, so you have to write the true value C, and this is again complement. Okay, so you have to write the D bar. Okay, and this will be A plus B bar plus C bar plus D. Okay, so this will be your expression. Okay, so the expression will be A plus B plus C plus D dot. Okay, A plus B plus C plus D bar dot A plus B bar C plus D bar dot A plus B bar dot C bar dot D. Okay, so this will be your expression. Have I done any mistake? Let's see. A B C D. Yes, A B C D bar. A B C D. A B C D. A B C D bar. A B bar C D bar. A B bar C bar. Yeah, I think it's correct because I got the same answers. Okay. Okay, so this is so you should be familiar with this notation only. Okay, so sometime you may be given a combination of these two. Okay, so I think you can realize them by yourself. That is not much difficult. Okay, so anyway, you have to familiar with this representation, because I'm not going to ask you to convert this to this one. Okay, but the question may be in this form. Okay, exam question may be in this form or in this form. Okay, so you have to familiar with this notation. Okay, okay, so we will do one example. We will try to find, we will try to simplify a Boolean expression using the QM method, Mcclusckey method. Okay, tabular method, and this time we will take product of sum expression. Okay, so we will take product of sum expression. Product of sum expression. Okay, okay, product of sum. Okay, no, product of sum. Yeah. Okay, so we will take example. Okay, I will take arbitrary example because I couldn't find anyone. Okay, so let's take this kind of one. A bar plus B bar plus C bar plus D bar. Okay, and you have A bar plus B bar plus C plus D bar. Okay, and you have A plus B bar plus C bar plus D bar. Okay, and you have A plus B bar plus C plus D. Okay, so this will be your example. A bar, B bar, C bar plus D bar, C D bar, A B bar, C bar, D bar, A B bar, C D bar. Okay, so we will try to simplify this using QM method. So what is the difference? The difference is the binary representation. Okay, so if it is a sum of product, normally if you when you are converting this to the this to a binary representation, when you are converting this to the binary representation, so you normally convert if you have uh, one, if you have a true value, you should write one, and if you have a complement value, you will write zero. Okay, and here you have to do the vice versa. Okay, here if you have a complement, you have to write one, and if you have a true value, you should have write zero. In this way, you have to convert the binary representation. Okay, convert this. So these are n terms, no? So this will be our 0, 1, this will be 1, and this will be 2, and this will be 3. Okay, and that is the only difference. Okay, when you are converting the binary representation, you have to consider this logic. Okay, so that is the only difference. Okay, so others are same. Then you have to group them. Okay, you have to group them from minimum ones to the maximum ones. Okay, then you have to pair. Okay, pair them uh, as we have discussed in our previous lecture. Okay, so can you I will give some time. Okay, can you try to do this by yourself? Okay, then we will try to do this. Okay, so this kind of question will come to your exam paper. Okay, so you should be thorough with this method. Okay, so maybe I will given a combinational logic circuits, and you have to find the Boolean expression. Then you have to simplify it using the Mcclusckey method. Okay, you have to simplify it using this method. Okay, other methods are not allowed. Okay, so can you do this by yourself? Then please take around 15 minutes and try to do the first few steps also. Then we will start. Okay. So if I doing any mistake, you can tell me, no? Okay. So please try to start the question by yourself. Then I will do this. Okay. So please take around 15 minutes. Okay, we will do this. Can you hear me, please? Can someone feedback? I think I got two answers. Okay, we will see. Can you hear me? Can someone feedback, please? Can you hear me and can you see my screen? Hello, can you hear me? Okay, thank you. Okay, thank you. So we will do this. So we have to first write the main terms. Okay. So we have M0, M0, M1, M2, and M3. Okay. So M0 is A bar, B bar, C bar, D bar. So in this case, you have to convert. If you have a true value, you have to write one, and if you have complement, sorry, if you have true value, you have to write 0. Okay, and if you have one, if you have complement value, you have to write 1. Okay, this logic you have to use. Okay, so I will use this logic. Okay, and I have 1, 1, 1, 1. Okay, so this is A, B, C, D. If I write, and M1 will be 1, 1, 0, 1. Okay, M2 will be 0, 1, 1, 1. Okay. And M3 will be 0, sorry, 1, sorry, 0, 1, 0, 1. Correct? Okay. So I think it is hope. I hope it is okay. 1, 1, 1, 1. 1, 1, 0, 1. 0, 1, 1, 1. And 0, 1, 0, 1. 0, 1, 0, 1. Okay, correct. No? Okay. Now we have to group this. Okay, we have write the, so our first step have done. Okay. We have write the binary representation. Okay. Then we have to group this. No, that is step 2. We have to group it. We have to do the grouping. Okay. And so how we should group? From minimum ones to maximum ones. Here also the same. Okay, from minimum ones to maximum ones you have to go. Okay, other steps are okay. Okay, so if I write so group 1, okay, so you can see that here you have 4 ones, here you have 3 ones, okay, and here also you have 3 ones, and here you have 3 ones. No? Okay, so you have to write 2 groups. Okay, so group 1 will be, sorry, this is 2, no? Here number of zeros are 2, number of ones are 2. Okay, so here number of ones are 4. In this M1, number of ones are 3, 1, 2, 3. And here also number of ones are 3, 1, 2, 3. And here numbers of ones are 2, 1, 2. Okay, so you can you will have 3 groups, no? So this will be your first group, okay, and this will be your second group, and this will be your third group. So you have 3 groups, okay. So the first group is M3, no, that is M3, okay. So the binary representation is 0, 1, 0, 1, okay. And the second groups are, so you have 2 groups there. First one is M1, okay. Here you have 1, 1, 0, 1. M2, you have 0, 1, 1, 1. Okay. So this will be your second group. Okay. 1, 1, 0, 1, 0, 1, 1, 1. Okay. And the third group, okay. So here I put the group number. Here I put the main terms, and here I put the binary representation. Okay. And that is M3, no? M0. That is 1, 1, 1, 1. Okay. So we have done the step 2. Okay. So if I am doing any mistake, please let me know. Okay. Okay. Now step 2 is okay. Now we have to pair them. Okay. We have to pair. Okay. So how to pair? So that will be step 3 in the same manner. Okay. That will be step 3. Okay. So how to pair? Okay. So you have to check. Yeah. Do you have any problem? Okay. Okay. So I have mute one student. I think mistakenly turn on the mic. No. Do you have any issue? Do you have any problem? Okay, I hope it is mistakenly happen. Okay, I have unmuted and I have muted his microphone. If you have any problem, please ask. Okay, you can now turn on your mic and you can ask. Do you have any issue or any clarification, doubt points? Okay, so we will continue. So step 3. Okay, so step 3 we have to pair. Okay, so how to pair? We have to pair normally n group with n plus 1 group. Okay, and how we pair? There should be only one mismatch. No, there should be only one mismatch of bits. Okay, there should be only one mismatch of bits. If we have only one mismatch, we can pair. Otherwise, we couldn't pair. Okay, so we will check. Okay, so I'm going to start. This is my first group. Okay, so first group I have to check with second group. Okay, so I have two selection. This is I have to check this one with this one, and also check this one, this one. Okay, so we will see. Okay, so you can see that here you have one mismatch. No, okay, so you have one mismatch. Okay, so you can pair this. Okay, this one M3 and M1 you can pair. Okay, so that will be our group 1 again. Okay, so this is the paired one. Okay, so I write the pair here, paired sequence. Okay, so I can pair M3 with M1. Okay, so you can see that this one and this one mismatch, so I have to put the underscore. Others are same. No, 1 0 1 1 0 1. Correct. If I am doing any mistake, please let me know. Okay, that is okay. And again I have to check M3 with M2. Okay, so I hope this is 0 1. Yeah, I think that can also be matched. No, that can be also matched. Okay, so that is M3 with M1. Okay, that is M3 with M1. Okay, so you have 0, you have 1, this one and this one. So I will write it here. Okay, so M1 is 0 1 0 1. Okay, and M2 is 0 1 1 1. So you can see that only these positions are changed. Okay, so I can write this as 0 1. If this is mismatch, you have to remove that. Okay, so you have to write the underscore, and here it is 1. Okay, 0 1 underscore 1. Okay, 0 1 underscore 1. Okay, so that is first, second. Now I have to group second with third. Okay, now I have to group second with third, so that will be my group 2. Okay, now you can see that if you have group, if you have paired any, if any of these sequence involved in pairing, okay, you have to put the tick. Okay, so here you can put the tick, and here also you can put the tick, and here also you can put the tick, because these are already involved in pairing. Okay, මේවා දැන් already අපි pair වෙන්න එකක් හරි එකපාරක් හරි pair වුණානේ මේ වගේ. ඒකින්ද we can put the tick. Okay, so I put the tick. Okay, now I am going to check. I'm going to check whether we can pair this group 2 with group 3. Okay, so I have to check. Okay, I will put this tick, this one. Okay, so I have to check this one with this one, and this one also with this one. Okay, so I have two selection again. Okay, So you can see that if I try to pair this one with this one, M1 is 1101 and this is 1111. I think we can pair, no? 1101, 111. Okay, so M1 is, okay, I will write here. M1 is 1101 and M0 is 1111. So this is the group 2 1 sequence, and this is group 3 sequence. Now I am going to check group 2 with group 3. Okay, so you can see that we have only one mismatch, so that we can pair it. Okay, so I can write it as 11_1, correct? Okay, so I write, so I can pair M1, okay, M1 with M0, no? Yeah, M1 with M0. So I have 11_1, no? 11_1. Okay. So so that's okay. And I also try to pair. Now we can put a tick, no? Because this one also involved at least one time in pairing. So I can put a tick. මේකත් එකපාරක් හරි pair වුණානේ. ඒකින්ද මෙතෙන්ට tick එකක් දාන්න පුළුවන්. Okay. But we can't stop. We have to check this one with the next one. Okay, because we have another sequence in group 2. Okay, so that one also you should check with this group. Okay, so I have checked this one and this one. Okay, you can see that this one same, and this one same. Only these 2 bits are different. Okay, so M2 also can be matched with, can be paired with M0. M2 can be paired with M0. So you will have, this is 0, 1 mismatch. So underscore. Okay. Others are same. No, 1, 1, 1. Okay. Others are same. 1, 1, 1. Okay. 1, 1, 1. Okay. So this will be our step 3. Okay. Correct. I hope I haven't done any mistake. Have I done any mistake? So can, I think some 1 or 2 students can answer, because they have already sent the answers. Okay, so your step 3 is same as my one. If not, we can check it again. Can one of you info, please? Any change here? Okay, we will quickly check this again. Okay, so I'm going to recheck this whether I am correct or not. Okay, so you have so I am going to group this group 1 with group 2. So we have to pair it. Okay, so M3 with M1. Okay, so only one bit is mismatch. Yeah, thank you. Answers are same, no? Okay, so we no need to check. Anyway, I will explain it again if you are not clear. Some of you, I feel that some of you guys are still not clear with these steps. Okay, so I will tell it again. Okay, so I'm going to group this. I'm going to pair this. Okay, so I have to check first one with the second group. Okay, so I have here, I have one sequence in the first group and 2 sequence in second group. So we have to check this one with this one and this one again with this one. Okay, so here 1 0 1 0. So you can see that M1 is 1 1 0 1. Okay, so you can see that these last bits are same. Okay, first bit is only change. Okay, so we can pair them. Okay, so you can put underscore and other bit are same 101. In the same manner, you can pair M3 with M2. Okay, M3 එක M2 එක pair කරන්න පුළුවන්. pair කරන්න බලන්න ඕන. හරි. එතකොට බලන්න මෙතන දැන් මේ bit එක එකමයි 1101 මෙතන bit position වෙනස් 11 same. හරි. එතකොට මේකයි මේකයි pair කරන්න පුළුවන්. M3 M2 pair කරන්න පුළුවන්. හරි. 0 1 මේ දෙක වෙනස් 01 වෙනස්. එතෙන්ට අපි underscore එක දාන්න ඕනේ. 01 underscore 11. So you can put 1 again. Okay, so like that you can pair. In the same manner, you have to pair the group 2. දෙවනි group එක with දෙවනි group එක තුන්වෙනි group එකත් එක්කත් බලන්න ඕනේ. Okay, you have to check the group 2 with group 3 also. So here group 2 you have 2 sequence and group 1 group 3 you have 1 sequence. So you have to pair all these sequence each other. Okay, so first try to pair M1 with M0, M1 with M0. Okay, so you can see that here you have 1101, here you have 1110. Only third bit is changed, no, 01. Okay, so you can pair 11 underscore 1. Okay, and in the same manner you have to check M2 with M0. So you can see that 111 111 same, and this is first bit is change, no, 0, and here it is 1. So you can pair. Only one bit is mismatched. Okay, so that is the condition. Okay, if 2 bits are mismatched, you can't pair. If 0 bit mismatch, again you can't pair. Right? You can pair only if only one bit mismatch. Right? bit දෙකක් හරි තුනක් හරි mismatch නම් pair කරන්න බෑ. ඒ වගේම bit එකක්වත් මේ වෙනස් නැත්නම් ඒත් pair කරන්න බෑ. හරි. pair කරන්න පුළුවන් නේ එක bit එකක් වෙනස් නම් විතරයි. හරි, ඒක මතක තියාගන්න. You have to keep remember that. Okay, so so this is M1 M0, sorry, M2 with M0 I'm going to match. Okay, so you can see that this one and this one same, only one bit change, so I can group it 0 1 1 1. Okay, so that is okay. So again you have to group. Okay, you have to do the same procedure. Okay, now you have only 2 groups. Okay, but you have to check 4 times because one group has 2 sequence. Okay, so I'm going to check. Okay, so that will be my step 3, step 4. Okay, so now I am going to check M3 M1 with M1 M0. Okay, so I am going to check this one with this one. Okay, so this one mismatch, this position now mismatch, this one match, this position now again mismatch. Okay, so here you can see that 2 mismatch are there, so you can prove you can pair, you can't pair. Okay, so I will write this M3 M1. Okay, that is 0 1 0 1. Now I am going to group it with the second group. So this is my second group. Okay, so this is my first group. Okay, this will be my first group and this will be my second group. Okay, first group එක ඇතුලේ දෙකක් තියෙනවා, second group එක ඇතුලේ දෙකක් තියෙනවා. ඒතකොට මට 4 පාරක් pair කරන්න ඕන. I have to pair 4 times. Okay, so now I am going to prove, I am going to pair first one with the first one. Okay, first one with the second group first one. Okay, so first one is underscore 101 and this one is 1 1 underscore 1. So you can see that here this one change, this one change, you can't pair. Okay, so this one and this one you can't pair. Okay, and you have to try this one with this one also. Okay, so if you try, you can see that here M3 M1 you have underscore 101 and M2 M0 you have underscore 111. I think you can pair, no, because these are same This is same, this is same, only this is different. Okay, so you can pair. Okay, so you can pair M3, M1, so that will be your group 1. Okay, so that will be your group 1. Okay, so you can group M3, M1 with M2, M0. Okay, so this group, so so uh, so this one can be group this one. Okay, so you can see that here you have underscore 1 1, and here you have 0 1. That means again underscore, no mismatch. Here you have to mismatch. Okay, and again you have 1. Okay, so underscore 1 0 1. Okay, then you have to consider this one also. Okay. Now you can put a tick here and here because this is involved in matching, but still you can't put here because it is still not matching. It is still not matched. Okay, it's still not paired. Okay, so you can't put a tick here. Okay, so this one and this one you can put a tick. Okay, now I'm going to check this one and this one. So that will be my first group, second sequence, second group, first sequence. So if I try to match, okay, so you can see that here you have mismatch. Here, sorry, this one and this one. No? Okay, I will write it here, otherwise it will be a confusion. So I'm going to compare M3, M1. That will be 0, 1, underscore 1. Okay, 0, 1, underscore 1. Okay, and I'm going to check this with M1, M0. M1, M0 is 1, 1, underscore 1. So you can see that this same, this same, this same, only this bit different. Okay, so you can pair this. That will be 1, underscore 1. Okay, so you can pair. Okay, so that means you can pair M3, M1. Okay, so I think this is M3, M1. This should be what? M3, M1. This should be M3, M2. No, I'm sorry. This should be M3, M2. Okay, this should be M3, M2. Correct? This should be M3, M2. Okay. I think I'm correct. No, this should be M3, M2. Yeah. Okay. Okay. So here M3, M1, M2, M0. Okay. Now M3, M2, M2 with M0. No, M2 with M0. Not M2 with 0. M1, M0. M3, M2, M1, M0. This one with this one. No? Okay. So here you can see that underscore because 0, 1 there. 1 underscore 1. 1 underscore 1. Okay. So again, I have to group, okay, I have to group this one with this one also. M3, M2 with M2, M0. M3, M2 with M2, M0. Okay. So how to M3, M2. So that will be 0, 1 underscore 1. M2. That will be underscore 1, 1, 1. So you can see that we can't pair because this one mismatch, this one mismatch. So two mismatches are there. So we can't match. Okay. So only we have this one. Okay. So if you try to match this again, so there is no any group, no. So you can't do any matching. Okay. only one group is there, so you can't do any matching. Okay, so you have to stop the matching, stop the pair. Okay, so you have to stop the pair in here. Okay, now you have to write the expression. So that is called implicants. No, can you remember prime implicants? So you have to write the prime implicants for this one. Okay, so this will be A, B, C, D. Okay, so this will be B. Okay, so this will be a sum. No, this will be a sum. So when you convert a sum, okay, if you have 1, you have to write the complement. If you have 0, you have to write the true value. Okay, so this A and D are not available. Sorry, A and C are not available. Okay, so you can see this one and this one not available, and you have this one and this one only, and this one you have 1, and this one also you have 1. So that means you have to write the complement, no, because this have 1. Okay, so you can write it as B bar plus D bar. Okay, and here also B bar plus D bar. Okay, so if you write only one time, that will be enough. Okay, B bar plus D bar. Okay, so this will be our prime implicant. Okay, this will be our prime implicant. So next, what we have to do? What is the next thing we should do? We have to find the essential prime implicant. No? We have to find the most essential prime implicant. Okay, prime implicant. Okay, for that one we have to draw, we have to prepare the prime implicant table. But here, is it necessary to do? Can someone feedback? Is it necessary to do to find the prime implicant? Can someone feedback? Is it essential to prepare the prime implicant table in this question? Yeah, yeah, that is okay. Okay, actually no need, no. Okay, so what about other student? I think that is okay. Uh, one student answer is okay. What about other student? Okay, actually this time we no need to prepare the prime implicant table, because we have only one prime implicant. Okay, so that should be essential, no. If you have two or three one, you can check others are needed or not, but here you have only one prime implicant, so it should be there, no, otherwise you don't have any expression, no. Okay, so so this will be your final answer. Anyway, we will try to put the prime implicant table. Okay, so how to draw the prime implicant table? First you have to draw the prime implicant, d bar d bar, and if you have more, you have to write those one also. Okay, if you have more prime implicant, you have to write them also, but in this case we don't have any. Okay, now, okay, now you have to write the momentums here. Okay, all the momentums here. Okay, so how many momentums we have? M0, M1, M2, M3. Okay, so you have M0, M1, M2, M3. Okay, so three, four momentums we have. Okay, now what is the next one? Okay, so we have to put a mark if these momentums are involved in this expression. Okay, so you can see that this for this expression you have m3, m1, m2, and m0. All implicants are involved. So you have to put the uh, mark for every terms, because in this expression, for this expression, all the terms are involved. Okay, so you have to put the mark. Okay, so if you have another terms also, okay, you have to do the same thing. You have to check uh, what are the terms. If you have any other prime implicants also, then you have to check what are the uh, implement what are the terms involved with this expression. Then you have to put the mark. Okay, if they are okay, but in this time we don't have. Okay, you have to put the mark if they are. Okay, then what you should do. Okay, you have to check this column. Okay, you have to check this column, and if column has only one mark, that one should be selected. That one should be selected. Okay, so for example, here if you consider this column, in this column only one tick is there, no? Only this column, only one tick is there. If you consider this column, only one tick is there. This column, one tick is there. This column, one tick is there. Okay, so only one tick is, if only one tick is there, you have to select that expression. Okay, so that is this expression b bar plus d bar. So you have to select that one. So f will be b bar plus d bar. So this will be your simplified answer. Okay, so I think that the student's answer is correct, no? Okay, she got the same answer. Okay, uh, so what about other? Did you get this? Or should we do another example? Please tell me. Okay. So we can check this. Okay, we can check this. So if you put the 1 1 1 1, so this will be 0. That means f will be 0. Okay, so here 1 and 1, again it will be 0, no? So maybe it is correct. Okay, and you can see that if you consider this one, if a and c are 0, b and d are 1s, okay, then whole expression will be 0. B and D are 1s. Okay, and if the B and D are 1s, again f is 0. So maybe this should be correct. Okay, so you can verify with this kernel map also. Okay, uh, so mm, so what about others? Can someone feedback, please? If you need to do any example, I can do it. Okay, so I think chapter 6 now. Okay, so you have this example. I hope have you done this example? Okay, did you get the answer? Okay, and in your reference book you have one example. Okay, workout example. And for a sum of product also, I think you have one example. This is product of sum. Okay, no, sorry, this is sum of product, and you have one example for product of ones also. Yeah, I think this one. No? Yeah, this one. Okay, so you have another example. Okay. Okay, so what's your opinion? Should we do this example, two examples, and someone feedback? Should we do one of this example, or shall we move to the next topic? Okay, we will do one more. Okay, so one student feedback that we will do one example. Okay, so shall we do this example? One of these example. So what should I do? Should I do the example one or example two? Or shall we do any arbitrary example? So what's your opinion? And also you should keep remember that when we are choosing the prime implicant, okay, uh, again you have to check whether we didn't put any tick mark. Okay, if you don't put any tick mark, that also should be taken as a prime implicant. Okay, that also should be taken as a prime implicant, otherwise your answer will be wrong. Okay, so what shall we do? What is the question we will try to do? Okay, we will do this one. Okay, so this is for multi-output function. Okay, so I'm not hoping to do multi-output functions. Okay, so I think you can adopt this. Okay, this method you can adopt this for any output. Okay, it will be not a big task. Okay, if you have the basic idea, you can use it in any case. Okay, so let me do another example. Okay, anyway, I will take another arbitrary example. Okay, so from a book or something, let's see, some examples are there in the exercise. So, okay, we will try to do this one. Okay, we will try to do this one. Okay, so what is that question? A, B bar, C bar. Write it somewhere. So you can also write this question. Okay, we are going to do this one. Okay, so this is a sum of product. Okay, A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C plus A, B bar, C. Okay, A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C plus A, B bar, C. Okay, so that will be our question. Okay. A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C plus A, B bar, C. Okay. So you can see that this is three variable function. Okay. So first thing is you have to write so this is sum of product. Okay. That is the first thing you have to note. This is a sum of product. So this is a sum of product. Okay, so when you are converting this to a binary representation, you have to write, if you have a true value, you have to write 1. If you have a complement value, you have to write 0. Okay, so that will be the logic. Okay, so I am going to, so this will be my main term 0, main term 1, 2, main term. Okay, 1, 2, 3. 1, 2, 0, 1, 2, 3. Okay, so I will write, so you have A, B, C. I will write M0, M1, M2, and M3. Okay, so it will be yeah, it will be uh, 0, 0, 0. Okay, and M1 will be 0, 0, 1, and this will be 0, 1, 1, and this will be 1, 0, 1. Okay, A, B bar C, 1, 0, 1. If A, 1, here you have a complement 0, here you have a true value 1. Okay, and here you have a complement. These are two values. Here you have a complement, here you have a complement. This is a 2. Here you have complement, complement, and here you have complement. Okay, so in this way we can represent the, we can write the binary representation. Okay, for these main terms. Okay, are you clear with this one? Okay, I hope it is clear. Okay, so now we have to group. Okay, how to group? We need to select the minimum number of ones to maximum number of ones. Okay, so you can see that here you have 0 number of ones, here you have 1 number of ones, here you have 2 number of ones, here again you have 2 number of ones. Okay, so that will be your groups. Okay, so this will be your first group because you have minimum 0 there. This will be your second group, and these two will be your third group. Okay, so I will write the group here. Okay, so I have group 1, that is in 0, that is 0, 0, 0, and I have the group 2, that is in 1, that is 0, 0, 1, and I have group 3. Okay, that is M2. Okay, 0, 1, 1, and group 3 I have M3, that is 1, 0, 1. Okay, so these are my group. This is group 1, this is group 2, and this is group 3. Okay, now I have to pair them. Okay, I have to pair them. So I have to, now this is my first step, this is my second step. Now I'm going to do my third one. Okay, so what is the third one? I have to pair. Okay, I have to pair in group with n plus 1 group. Okay, so this is the first group with the second group. Okay, so this one and this one I have to pair. Okay, so you can see that if it is paired, no, because only one mismatch is there. Okay, so that will be my new group 1. Okay, so I can pair M0 with M1. Okay, so you have 0, 0 underscore. Okay, 0, 0 underscore. Okay, now yeah, that is the group, that is the first one with the second one, because we have only only two sequences in both groups. Okay, so we have to pair only one time. Okay, now you have to group the second group with the third group. Okay, this one with this one. Okay, at that time you have to do 2 times it. Okay, because you have, here you have one sequence, but here you have 2 sequences. Okay, okay, because this one and this one already paired. Okay, so you can put the tick. Okay, now I'm going to pair this one with this one. Okay, so you can see that M1 and M2, this one 0, this one 1, only this bit mismatch. So I can match that one, no? Okay, so that will be my group 2. Okay, so I can match M1, I can pair, okay, M1 with M2. Okay, M1 with M2. You have 0, 0, 1, that is mismatch. So you have to put the underscore, and 1, 1. So you have 1. Okay, 0 underscore 1, M1 with M2. This one also involved in matching. Okay, now I have to check this one with this one. This one change, this one same, this one same. That one also you can match, no? Because M1 you have 0, 0, 1, M3 you have 1, 0, 1. Okay, so these two are okay. Only these two are mismatch. Okay, so you can group them. Okay, so that is your group 2. Still you are in group 2, no? Okay, so you can match M2, sorry, M1 with M3, M1 with M3. So what is the answer? You will get underscore 0, 1. Okay, so you have again two groups. Okay, again you have to do the matching. Okay, again you have to do the matching, and this one also involved in matching, so you can put a tick. Okay, so you can forget this table because every times you have tick. Okay, so you can forget this table. Okay, because in every position you have a tick, that means you can ignore. Okay, that part is not included in prime implicant. Okay, so you no need to consider this table anymore. Okay, if you haven't any if you haven't put any tick, for example, in this place, in this sequence, if you couldn't pair with anyone, okay, what make එකක් එක්කවත් pair කරගන්න බැරි වුණොත් එහෙම, you have to put you don't have to put the tick mark, you have to put a special mark. Okay, or marker special mark එකක් දාගෙන තියාගන්න ඕන. Okay, then when you are selecting the prime implicant, you have to select this one also as a prime implicant. Okay, so here it is 0, 0, 1. So here A bar, B bar, C also will be a prime implicant. Okay, here it is not confused කරගන්න එපා. මම කිව්වේ බැරි වෙලාවත් මේක pair දුන්න නැත්නම් දැන් already ඒක pair වෙලා තියෙන්නේ. pair වුන් නැත්නම් ඒ කියන්නේ මේ එකක් එක්කවත් මේ අනිත් එකක් එක්කවත් pair වුන් නැත්නම් මේකට ඔකට මොකක් හරි මාක් එකක් දාලා තියාගන්න ඕන. ඊළඟට අර prime implicant ලියන වෙලාවේදී මේකත් prime implicant එකක් විදියට ගන්න ඕන. මොකද මේක එකක්වත් pair වෙලා නැති හින්දා. හරි? එතකොට ඔයාලට ලියන්න වෙන්නේ මේක A bar B bar C කියලා. මෙන්න මේක ගන්න ඕන prime implicant එකක් විදියට. දැන් එහෙම ගන්න ඕනේ නැහැ. හරි? You no need to take this one. Okay, that is for example. Okay, I just tell it. Okay, don't get confused. Okay, okay, so now we have to do another matching. Okay, another pairing. Okay, that will be my fourth step. Okay, so you have to match this one with this one. Okay, so you can see that this one, this one, this one not same, so it is not matched. Okay, okay, so M0 and M1 not matched. Okay, and if you consider this one and this one, it is also not matched, no? Okay, this one and this one also not matched. Okay, so you can't match anymore, no? So this is the only time you can match, correct? You can't match this one with this one and this one with this one. You can't match. Okay, okay, yeah, you can't match, no? Okay, so you have to stop matching. Okay, you have to stop matching and you have to draw the prime implicant here. Okay, so what are the prime implicant? Okay, so here you have a prime implicant A bar So this is sum of product. Okay, this is a sum of product. Okay, so you have to product. You have to write the product value here. And if you have 0, you have to write the complement value. If you have 1, you have to write the true value. If there is no, if it is underscore, you don't have to write anyone. Okay. Oh, shit. What is the value here? I can't remember. It is M0 with M1. No? So it should be 0, 0 underscore. No? This is there. No? Okay. M0 with M1, 0, 0. Yeah. Okay. So you have to write A bar plus B bar. This is A, B, C. A bar plus B bar. And here you have to write A bar C. Okay. And here you have to write B bar C. Correct? A bar, B bar, A bar C, B bar C. Okay. So these are the prime implicants. Okay. So in this case, you have to write. So here you know other tables, all other tables you have put ticks. Okay. So that you don't have other prime implicants. Only these prime implicants are there. Okay. So you can prepare the prime implicant table. Okay. So here you have A bar, B bar. Here you have A bar C. Here you have B bar C. Okay. So these are the prime implicant. Now you are going to find the essential prime implicant. Okay. You are going to find essential prime implicant. Okay. For that one, okay. So you have to write all the terms here in 0, M1, M2, M3. Okay. So you have to put all the terms. Okay. Okay. Now you have to write, you have to put the tick. Okay. So for this one, A bar, B bar, you can see that M0 and M1 involved, no? M0 and M1 involved. Okay. And A bar C, you have M1 and M2. Okay. M1 and M2 you have. Okay. And for this one, you have M1 and M3. M1 and M3. Okay. So you have to choose this column, only these columns, only this tick, only this mark, only one mark is here. Okay. So this column you have to check. Okay. So you have to get this implicant. Okay. A bar, B bar. Plus here you no need to consider. And this one also you have to consider. And it is A bar C. Okay. And others are no need to consider. No. Here also you have one column. Okay, you have one row, one column. Okay, so you have to also consider this one also. Okay, so all prime implicants are there again. Okay, so this will be your answer. Okay, so this will be your answer. A bar B bar, A bar C, B bar C. Okay, okay. So is that clear? Yeah, thank you. So whether can we check whether this is correct or not? Our answer is correct or not? Okay. So you have here A bar, B bar, C bar. Okay. So you can get A bar, B bar here. Okay. And you have C bar plus C. So that will be 1. So you have A bar, B bar. Okay. And here you have A bar, B, C. Yeah. So shall we try to do this using a kernel map? Okay. can you check this with the kernel map, and can you verify the answer is okay or not? Okay, please get 5 minutes. Try to find the answer using the kernel map. Meanwhile, I am trying to do this using the kernel map. Okay, I will do this using the kernel map. Okay, and we will try to verify this answer. Okay, whether it is correct or not. Okay, so you have F A bar B bar C bar plus this one. No? I will take this one. Okay. Oh, this one. No? So I will select this. This time I think this. Copy paste. Okay, no. Okay, so this is our expression. Okay, now I am going to draw a kernel map. Okay, so this is 3-variable kernel map. Okay, so here I will use A B. Here this point I will use C. Okay, so here you have C bar, that means 0 and 1. Okay, okay, and here you have 0 0 0 1. This is 1 1, no, 1 1, and this is 1 0. Correct? I write the correct manner, no? This is 0 0 0 1 1 1 1 0. This should be changed, no? 0 1 4 3. Okay, in that manner I have right, no? 0 1. Okay, so you can see that this one I have 1. Okay, because 0 0 0 are there. Then 0 0 1 is there. This one is there. 0 0 1. Then I have 0 1 1 0 1 1. This point I have 0 1 1, and again I have 1 0 1 1 0 1. Okay, so this I have, no? Correct? Is that correct? Okay, I think I'm correct. Okay, so I think we have to group this one. Okay, thank you. Okay, so we have to group this one, and also you can group this one. and you can group this one and this one, no? Correct? Okay. So I think okay. This one you can group, this one you can group, and this one you can group. Okay. So here you have, if you consider this one and this one, this group, you have have I done correct manner? This can in this way we can group, no? This one we can group, this one we can group, and this one and this one we can group. Okay. So here I have uh, 0, 0. So I have A bar, B bar here, no? 0, 0, and 0, 1 cancel out. A bar, B bar I have. And if you consider this one, I have this one cancel. Sorry, this one B bar cancel, no? This one cancel, and I have A bar. Okay. If you consider this one, okay, this group I have A bar, this one cancel, this one, sorry, this one cancel, B cancel, A bar, and C. Okay. And if you consider this one, you have this one and this one. So that means this one and this one, the A cancel, you have B bar, C. Correct? So I have A bar, B bar plus A bar C plus B bar C. Okay. So the same answer, no? A bar, B bar, A bar C, B bar C. Okay, so our answer is correct, no? I hope you get it, no? The kernel map I'm not going to do here, okay, because already you have done this, no? And in this, if you have already forgotten, in the same manner you will do it again, no? දැන් මේ කට්ටිය ඔයාට කරන මැප් එක අමතකයි නම් ඕක දැන් මේ පාර ඉගෙන ගත්ත කියලා වැඩක් නැහැ. ඉතින් මේක එක්සෑම් එක ලියපුවම ආපහු අමතක වෙනවනේ නේ. ඒකින්ද අපි වැඩක් නැහැ මේ කරන මැප් දැන් කලින් ඉගෙන ගත්තා නම් 5 variables වලට එනකල්ම කරන මැප් ඉගෙන ගත්තා නම් අපි මේකෙදි කරන මැප් කරන්න යන්න ඕනේ නැහැ. මම එක්සෑම් එකට කරන මැප් දෙන්නෙත් නැහැ. මම දෙන්නේ මේකේ මේ Mcclusckey method එකෙන් solve කරන්න තමයි. හරි. හරි නේද එතකොට මේක? Is that okay? Okay. And please wait 2 minutes. Okay. Yeah. I will upload the lecture. Okay. So okay, we will do lab session. Okay, we will actually those are not lab session. Okay, we are just practicing these things. Okay, in the lab, but you have some labs. Okay, those labs you have that is compulsory to attend to the labs. Okay, so you will get some marks. Okay. So in the interaction session, we are doing something in the labs. Those are not actually labs. Okay. තේරුණානේ කියන එක. ඒවා අපි labs නෙවෙයි කරන්නේ. නිකන් අර මේවා practice කරන එක විතරයි. ඒ වුණාට ඔකටට proper lab තියෙනවා. එතකොට ඒවා කරන්නම ඕන. ඒවට ලකුණු හම්බ වෙනවා. හරි. ඔය දැන් interaction session මේ දැන් Monday තියෙන එකට compulsory නෑ ඔය කට්ටිය එන එක. එනවා නම් හොඳයි. හරි. We can do some practical things there. Okay. But it is not mandatory. Okay. එන එක අනිවාර්ය නෑ. Okay, just give me one moment. Okay, so in LO1, okay, LO1, we have to learn about combinational and sequential logic circuit. Okay, and combinational logic circuits. Some arithmetics logic circuits are combinational one. Okay, so I think this is not much hard. Okay, uh, using a truth table, you can implement this type of combinational circuits. Okay, and you can analyze it easily. Okay, uh, in this LO1, we will mainly focus on logic, sequential logic circuits. Okay, sequential logic circuits. Okay, and it under this we have to discuss uh, flip flops. Okay, flip flops and counters, registers, that kind of logic circuits. Okay, so if I hope we will start this in next week, sequential and logic circuit. Okay, and I think you have already learned the flip flops stuff, no? Flip flops you have already discussed, you have already learned. Okay, uh, so have you learned the flip flops? I think you should have the basic knowledge. At least you should learn the RS flip flops and JK flip flops and D-type flip flops. I think you should have learned these things. Okay, and we will start. So here we no need to start, no? So you can please refer this reference book and you can refresh your memory on this. Okay, RS, JK, and D-type flip flops. Okay. Okay, I will upload the examples. Okay. But I will upload this later. Okay. Not today, because once we completed the LO1, I will give you a questions. Okay, I will give you some questions. Okay, so you have to answer those questions, but no need to send. Okay, I'm not going to evaluate them. Okay, that is for your reference. So once you have write the answer for that answer questions, okay, that will be your note actually. Okay, so your note should be prepared by you. I just only give you a guide. Okay, I will give you some questions. Okay, then you can write the answers for that questions, and that will be your note. Okay, so for that I will included these examples also. Okay, so when you are writing the answers, if you can't remember, you can refer this lecture and you can write them. Okay, then you will again remind it, no? Okay, so that will be your note. Okay, so I am not going to give you any note actually here. Okay, that is not necessary, no, that is not needed actually. If I am give you a note, සාමාන්‍යයෙන් අපි කරන්නේ reference book එකෙන් copy කරලා දාන එකනේ. හරි, we just copy it from a reference book and put into it on the slide. Okay, put it onto a slides onto slides PPT. Okay, so I think that is not necessary, no? So I will give you a question list. Okay, so once you have write the answers, so you can refer the reference book and you can write the answers. Okay, then that will be your note. Okay, so the actually at that time you are doing some self-learning things also. Okay, so that also will be important for your life, I think. Okay, so I will use that method. Okay, okay, so what I want to tell you is that, okay, so we will next lecture we will start from sequential logic circuits with counters and registers. Okay, counter and registers. Okay, so you for this circuits you have to use the flip flops actually. Okay, so please try to refresh your memory on these basic type flip flops, RS, JK, and D type flip flops. You can refer the book, and I hope you can come with that knowledge. Okay, so that we can directly start this stuff. Okay. Okay. Shall we wind up? Have you any question? If you have any question, you can ask me. Okay.